See, everybody will be telling you, please look at the previous year questions. Of course, the previous year questions are very important, but you need to understand the trend as well. See, from 2011, if you see from 2011 to 2015, from geography there were around 15 to 20 questions. Then from 2017, because the 2016 paper, if you see, it is not of UPSC standard, you can ignore 2016 paper. So from 2017 to 2025, I would say 2024. So the number of geography questions were less. So geo questions were less. So UPSC, always has an element of surprise. So if in this year the geography questions were less, doesn't mean that next year they will not increase. In fact, in 2025 they have increased the geography questions. They have come back to normal from 15 to 20 questions again. So this year also, again this trend will continue for few more years. So they will be asking geography question. Now here you will be specifically focusing on prelims. Okay, since you guys haven't done geography properly earlier, so I'll be taking it as a crash course. So along with the prelims, I'll also give you a crash course. I will teach you the static content. So along with the static content, we'll also go with the questions. So for every topic, which all questions will be asked, I'll be telling you. Now, as far as this topic is concerned, so obviously, okay, we'll be studying the geography, right? Geography. There is something called as the principle of centrality. See, every atom has a nucleus. The moon is revolving around the earth. The earth is revolving around the solar system. The solar system is revolving around the Milky Way galaxy. And this galaxy is part of the local cluster. And this local cluster is part of supercluster. And this supercluster is part of the universe. Now, from this portion, okay, see, if you have to understand geography, geography is the study of earth. Then for studying geography, you need to understand a bit of universe also. So that's why you'll be doing the basics of the universe. But this topic of universe is a mix of science and technology as well as geography. So I will not give much insights about science and technology, but again, whatever science and technology you have studied before, I'll be able to give more inputs than that only. And very, very important thing, don't be lazy now. Take running notes. Because as long as you are taking running notes, you will be actively listening to the class. Of course, whatever information is there, it is there in your PMF IAS booklets. Lot of information is there. But what information is important for the exam, what is not important for the examination, we will discuss here. So first, to understand geography, geography means the study of the earth. So keeping the principle of centrality in mind, we'll be studying the universe now. Now only that part of the universe we'll be studying which will be useful for geography point of view. Now, if you want to study about the earth, then you have to study a little bit about the solar system. So if you want to study about the earth, you have to study little bit of solar system. Now if you have to study about the solar system, you have to study little bit about the universe. Now again, okay, since you haven't done the foundation very well, now geography is study of the earth, but which part of the earth you'll be studying? See, geography is nothing but geography is the relationship between the man and environment. You can say human and the environment. So, since it is a relationship between the human and environment, so geography is equally human. So geography means you will be generally studying about physical geography. So if you want, I'll be sharing my class, okay, handwritten notes also. So in my handwritten notes, the people, okay, my students have written everything whatever I utter from the mouth. Okay. So this is very, very important aspect. In fact, in the first page you should be writing this only. So geography is, because this is very useful when you will be writing the mains examination. Though it is not useful now, but again I am telling you as a passing reference. So geography is equally human. See, even though the physical aspects has been asked in the examination. For example, okay, they have asked the question previously, okay, Pacific Ring of Fire. So you should not just talk about the geophysical aspects of the Pacific Ring of Fire, but also you should talk about the human aspects. Means how these physical aspects are affecting the humans. That is very important. So that is what this man-environment relationship is. In fact, the half of your answer should be human. And what you should be writing in the conclusion. So in the conclusion, you should always have the concern about the environment. So this you pinpoint in the first page itself. So what are the important points here? Geography is man-environment relationship. Geography is equally human. And the conclusion should be always towards the concern towards the environment, environmental destruction, etc. So if you understand these principles, then whatever current affairs might come, you will know what exactly to focus on. So physical aspect, it affects on human, and what will be the effect on the environment. Okay. So these three aspects will be focusing on, and if you look at the previous year questions, means especially after 2011, you will see a lot of concerns. Even if you look at the mains examination, you will have a lot of concern towards the environment. You see the paper 3 also, okay, of course environment is there, disaster is there, and even in paper 1, more than half of the questions they show a lot of concern towards the environment. For example, the earthquake is coming, tsunami is coming. They will ask, what are the impacts on the human, and then how the environment will be affected. Okay, so these things you should focus on. So this is what, okay, you should be drawing from current affairs, because whenever you read the newspaper, you'll be confused. इसमें क्या पढ़ना है, क्या नहीं पढ़ना है, क्या याद रखना है, नहीं रखना है. So through the various topics, I'll be telling you what to focus on, what not to focus on. Now next, talking about the universe. Now what is this universe made up of? Keep noting down all these things. So what the universe is made up of? So composition of the universe. If you take the composition of universe, I'll be drawing this diagram now. Now less than 4%, we can round it off to 5%. Round it off. See, figures always you should round it off, because for this examination you have to remember 400 to 500 figures. So you cannot exactly remember all the facts and figures. That's why it's always better to round it off. Now around 5% is matter. That is what you see. The stars, planets, nebula. Nebula is nothing but a cloud of gas, which we'll be discussing later on. Now this is the matter, and 23%, around 23% is dark matter. Now you'll be reading a lot of articles on dark matter. Then you'll be confused what to focus on, what not to focus on. So the dark matter is such matter which is not visible. It is not visible. Now why this is not visible? Because it does not emit light. Then how do you know this dark matter is existing? Because it affects gravity. So we'll be seeing 2-3 examples. So it has gravity, but it is not visible. It does not interact with the light. It does not reflect, refract, diffuse, or absorb light. So that's why it is called as dark matter. So there are certain phenomena here which you'll be studying in science and technology, called as this gravitational lensing, etc. Here also I'll discuss it a little bit. Now there is one more thing. Okay, there is some energy in the universe. Okay, so when you go to a Baba or somewhere, So they'll be saying that यहाँ पे positive energy है, negative energy है. Positive negative energy कुछ नहीं होता है. So there is something called as dark energy. Now why it is called as dark? Because we don't know anything about it. We don't know anything. This also why it is called as dark? Because we don't know anything. But how do we know it is there? Because dark energy is responsible for the expansion of the universe. Expansion of the universe. Means there is some invisible energy in the universe which is pulling these galaxies apart. The galaxies are running away from each other. So there is some push energy. Now this dark matter is pull because it is affecting gravity. So in very simple sentence, if you don't have any idea about dark energy and dark matter, I'll tell you. For example, this is galaxy 1 and this is galaxy 2. So this galaxy is intact. So this galaxy is not diffusing away. It is held by some energy which we don't know. So it is dark matter. So within the galaxy you have the dark matter, and in between the galaxies you have dark energy. So even if you know these things, great. Now even I want to know how much you know. Yes? See, if you're familiar with all these things, then let me know. I will not be wasting your energy and time by explaining such kind of trivial things. Okay? I want your review. I want you to interact with me. You should guide me, because if you guys were in the class, I would have seen your faces and get to know, what you don't know. Now you guys tell me, are these things new to you or alien to you? Okay. Familiar? Okay, fine. So even if you're familiar, I'm simplifying this. Okay, good. So only these things, if you know, familiar? Okay, fine. So even if you know these things, this is more than sufficient. Now, because more you'll be reading in the science and technology. Now, next, as far as geography is concerned, so formation of universe. Formation of universe. Because if you want to know the formation of the earth, what is the earth made up of? You should know the formation of the universe itself. Universe. Now there are various theories, okay, which explain the formation of the universe. Now for example, okay, you guys go to the interview and the interviewer is asking, okay, beta, okay, one familiar question will be, okay, what are the priority areas when you enter into the civil services, okay? Or they can ask you, this question has been asked to me, so they have asked, now what kind of method you will prefer? Okay, will you go for a revolutionary approach or will you go for an evolutionary approach? Evolutionary means slow and gradual changes. Revolutionary means sudden changes. Sudden changes means, okay, one person will be coming on the TV at 8 PM and saying that, मित्रों, कल रात 8 बजे के बाद आपका जो भी पुराना नोट है वो पूरा delegitimize हो जाएगा, something like that. That is totally revolutionary, all of a sudden change. Okay, so what will you prefer? When you enter into administration, you want some revolutionary approach or evolutionary approach? See, your answer should be middle path. It should not be completely evolutionary, because evolutionary means slow and gradual changes. Revolutionary means sudden. Okay, so it should be both. Now, what is revolutionary and what is evolutionary in this? Now, if you take the earth, in the earth you have concentric circles. You must have heard this. The core, mantle, crust. They are so beautifully arranged. Again, if you take the solar system, all the planets are so beautifully arranged, right? So such kind of arrangement must have happened by a evolutionary process. And this evolutionary process of the formation of the universe, the pioneers of this are Laplace and Kant. Something called as, they have come up with something called as the nebular accretion theory. Nebular accretion theory. Again, these kind of things, they will not be asking in the examination, but still, okay, you need to have a crux of what is happening here and why I have taken this topic. So the universe is formed because of this slow evolutionary process. Because of that, things are so beautifully arranged. There is a set pattern for the things. But again, don't you think there is no randomness in the universe? Don't you think there is revolution also in the universe? Sudden changes? Yes. Now what is this sudden change which happened in the universe? So this is called as the Big Bang. So the universe is a byproduct of chaotic processes and slow and gradual processes. Now if you are going to the interview and they will be asking what kind of changes you will do in administration. Sir, okay, I believe in the theory of the universe. Okay, I am a student of nature. Okay, since I believe that nature is the best teacher. Even in nature, the processes have been revolutionary. Also, they have been evolutionary. In the same fashion, I'll also do changes. So whenever the things demand, I will go for radical changes. And to adapt to the radical changes, I'll also go for slow and evolutionary changes in the administration. So like this. See, Kalyan Reddy, okay, you should be writing the notes. Okay, then only you'll be active. Or else, whatever I am telling, there is a hell a lot of material in the market. It's there everywhere. But still, if you want, okay, handwritten notes, you can message me. Okay, one of my students, have written all these things. I'll send it to you. Okay, because it's handwritten, it's not printed and all. I can't do that clerical work. So it's better. Okay, you write all these things. So the universe is a byproduct of a revolutionary process as well as evolutionary process. Now what is lying in between, we'll see, right? So from the Big Bang to the formation of the earth, it has been around 13.8 billion years. Okay. Now again, other things you'll be learning in science and technology, but again I'm asking you, see, everybody knows, you guys told me that you know a lot of things, right? So let's say assume the universe, the formation point is this. At this point the universe has been formed. So this is the point of the Big Bang. Now you all guys agree that nothing can travel faster than light. Okay, Suraj, okay, मैं हिंदी में भी आपको संबोधित करूँगा. My Hindi is very bad. Okay. So do you guys agree that nothing can travel faster than light? अगर कोई चीज़ यूनिवर्स में लाइट से फास्ट जाती है तो क्या होता है वो मुझे बताओ कमेंट सेक्शन में. ओके, क्या होता है? कैन यू टेल? सी, डोंट गेट स्केर्ड, नोबडी इज जजिंग यू. सी, यूनिवर्स के बारे में किसी को कुछ पता ही नहीं है. आप जो भी बोलोगे सही होगा, उसके ऊपर थियरी भी निकल सकती है. अगर कोई भी चीज यूनिवर्स में अगर लाइट से फास्टर जाती है, its mass will become infinite. Mass will become infinite. And mass infinite नहीं हो सकता है. तो इसी चीज़ के लिए तो आइंस्टीन को ओके ये नोबेल प्राइज मिला था. ये तो खोज किया था यही चीज़ बोलने के लिए कि कोई भी चीज़ लाइट से फास्ट भागती है तो उसका मास इन्फिनाइट हो सकता है, एंड मास इन्फिनाइट नहीं हो सकता है. दैट्स व्हाई नथिंग कैन ट्रैवल फास्टर देन लाइट. नाउ आई एम आस्किंग यू वन मोर क्वेश्चन. No, nothing can travel faster than light. No, what is the age of universe? Around 13.8 billion years. Means after the universe has been formed, see, चीजें इस तरफ गए होंगे, इस तरफ भी गए होंगे. In a spherical, they have spread, right, in 3D. तो फिर what should be the diameter of universe? Means इस तरफ 13.8, इस तरफ 13.8. Means पूरा कितना होना चाहिए? 13 plus 13, 26, 8 plus 8, 16. Means 27.6 billion years. So, the expanse of the universe, you can say the diameter of the universe, अभी तक किसी को यूनिवर्स का शेप नहीं पता, but let's assume it's spherical in shape. So, the diameter of the universe should be 27.6 billion years. ये सही है कि गलत है बताओ? Is this right or wrong? False. See, लेकिन एक गलत है. Sir, the expanse of the universe is 93 billion years. ये नंबर कैसे आया? So यहां से यहां कैसे जंप किया? See, मैं आपको सोचने की मजबूर कर रहा हूं. See, यूपीएससी में आप जितना भी पढ़ लो भैया, आपको 30 क्वेश्चन से ऊपर आप पढ़े नहीं होंगे चीजें. 70 क्वेश्चंस में आपको आपका दिमाग लगाना है, एंड जब भी आप पढ़ते हो आप पैसिवली नहीं पढ़ना है, आपको सोचते हुए पढ़ना है. ओके, यू टू हैव टू कम अप विथ योर ओन एक्सप्लेनेशन. सी, जस्ट नाउ आई टोल्ड यू, यहां पे क्या बताया मैंने आपको? डार्क एनर्जी बताया ना भाई. एक्सप्लोजन हुआ था, बट इवन आफ्टर द एक्सप्लोजन देयर वाज डार्क एनर्जी इनसाइड द यूनिवर्स, and this dark energy is responsible for the expansion of the universe. So that's why nothing can travel faster than light. That is true. So इसके हिसाब से यूनिवर्स का जो डायमीटर है इतना ही होना चाहिए, लेकिन भैया बीच में ना डार्क एनर्जी आ गया, वो यूनिवर्स को पूरा एक्सपैंड कर दिया. That's why the expanse of the universe is around 93 billion years. So सब चीज में लॉजिक लगाना है, एंड जब तक आपको लॉजिक पता नहीं होगा यूपीएससी का क्वेश्चन सॉल्व नहीं कर पाओगे. ओके, सो दिस आर सर्टेन बेसिक्स अबाउट द यूनिवर्स एंड यूनिवर्स फॉर्मेशन. नाउ दिस इज हाउ ओके रफली द यूनिवर्स विल लुक लाइक. लेकिन ए यूनिवर्स कैसे फॉर्म हुआ था, मीन्स यू नो व्हाट आर द बेसिक एलिमेंट्स ऑफ द फॉर्मेशन ऑफ द यूनिवर्स. ओके, लेट्स सी दैट. See, again, you know, whenever you're getting doubt in the examination, go back from the basics. आपको जो भी चीज पता है पहले वो चीज लिखो. अभी मैंने आपको क्वेश्चन पूछा, so what is the matter made of? आपको क्या पता है? See, at least आपको ये पता है ना. See, you have the core, mantle, crust. Core, mantle, crust. Now what are these made up of? Okay, at least आपको पता है. Okay, these are made up of some elements. Okay. Now elements में क्या होता है? In elements में you have the nucleus. Nucleus में you have neutrons and protons, and you have the electrons. So you have the electrons in the fixed orbits. ये चीज तो पता है. अरे ये एटम कहाँ से बने, या न्यूट्रॉन प्रोटॉन इलेक्ट्रॉन कहां से बने, राइट? एंड व्हाट इज द मोस्ट सिंपलेस्ट न्यूट्रॉन ओके और प्रोटॉन कॉम्बिनेशन, राइट? सी, द वेरी बेसिक एटम इज हाइड्रोजन विच हैज प्रोटॉन इनसाइड द न्यूक्लियस एंड यू हैव दिस इलेक्ट्रॉन. भैया ओके, ये चीज कैसे बना? ये प्रोटॉन हुआ और इलेक्ट्रॉन हुआ, ये चीज कैसे साथ में आया? नाउ these have been made up of something called as, so ये होता है, ये चीज होता है, प्रोटॉन इज मेड अप ऑफ समथिंग कॉल्ड एज क्वार्क, एंड इलेक्ट्रॉन जो है लेप्टॉन है. इसके बारे में इन डिटेल यू विल बी स्टडिंग इन साइंस एंड टेक्नोलॉजी, समथिंग कॉल्ड एज स्टैंडर्ड मॉडल ऑफ फिजिक्स. वेरी गुड. ओके, रितिका, फातिमा, बहुत बढ़िया. क्वार्क, क्वार्क भी है, लेप्टॉन भी है, आपने लेप्टॉन भूल गया, हाँ, राइट? Now, what is this quark made up of? So, quarks are made up of something called as quark gluon plasma. इतना तो पता है. Okay, very good, Rohit. Okay, 2 up and 1 down. Good. Now, quark gluon plasma. ये किस चीज से बना है किसी को नहीं पता, नो वन नोस, नो वन नोस. Now it is an assumption that there is a light, or you can say energy, and there was humongous amount of energy in the universe, infinite amount of energy in the universe, and this infinite energy has been converted into matter. So basically in the universe there was only energy, and this energy has been converted into mass. एंड ये वाला फॉर्मूला हम अभी तक यूज करते E इज इक्वल टू एम सी स्क्वायर, लेकिन जितना सिंपली ये बोलते हो उतना सिंपल नहीं है. तो फिर बिकॉज यू नो वी नो ओनली अबाउट द मैटर इन यूनिवर्स, यू डोंट नो अबाउट डार्क मैटर एंड डोंट नो अबाउट डार्क एनर्जी. सो एनर्जी, हाउ इट हैज बिकम quark and how it has become, okay, various elements, and how this iron, nickel which is there in the core, silicates, ferrous and magnesium silicates which are there in the mantle, and crust में lighter silicates, ये सब कैसे form हुआ ये तो पता है, लेकिन ये नहीं पता है. Now one more question which is related to this, okay, I will ask you, okay, you should answer. अभी इसके related experiments, भैया क्वार्क ग्लूऑन प्लाज्मा से क्वार्क बनता है, क्वार्क से प्रोटॉनवा बनता है, ये चीजों का एक्सपेरिमेंट कहां पे होती है ये बताओ. वेयर ऑल दिस एक्सपेरिमेंट्स लाइक बिग बैंग आर कंडक्टेड. वेरी गुड, ओके, LHC, Large Hadron Collider. Okay, very good. So about these things you'll be studying more in science and technology. So basically LHC is one of the loops. This facility is called as CERN, CERN, means European Center for Nuclear Research. So once already the question has been asked, CERN में जो भी होता है, जब भी कुछ revolutionary चीज पता होके आती है, UPSC हमेशा क्वेश्चन पूछता है. So please आप ध्यान रखना. So a universe कैसे form हुआ? So initially something called as Big Bang has happened. So the Big Bang has released energy, and from here the universe has been expanding. यहाँ से universe expand हो ही रहा था. So in the initial stages the universe was expanding at a accelerated rate. Means the rate of expansion of the universe also varies. कभी कभी बहुत ही expand हो जाता है, कभी कभी कम expand होता है. So this is called as accelerated rate. So initially बहुत ही ज़्यादा expand हो गया था, and this Big Bang, okay, has given rise to energy, and this energy has given rise to something called as quark, gluon, plasma, and from here the quarks have come, and from the quarks the first element has been formed. The first element is the proton, and also later on the leptons have been created, that is electron, and this is how the hydrogen has been formed. So hydrogen is the basic fuel of the universe. लेकिन जो पहले का जो हाइड्रोजन था, so that was, okay, located at, okay, a small location. Later on it started expanding, and its hydrogen के clumps बने. It expanded, and because of the gravity, so the hydrogen molecules, they started coming together, okay, because of the accretion. And when the hydrogen they started coming together, because of the gravity, okay, so whenever the gravity increases, the temperature also has increased. And because of the increase in temperature, the nuclear fusion reaction has started. See, these things I am telling you, ऐसे बता रहा हूँ क्योंकि science and technology में पढ़ोगे आप. So the hydrogen has come together. Okay. Now what is important as far as our geography is concerned, I will tell you. So as far as our geography is concerned, So this is how the universe has expanded. So the first stars have been formed around 400 million years ago. Then later on, the hydrogen has come together and more nebulas have been formed. Then the galaxies and planets have been formed, and because of dark energy, the universe is expanded. Okay. Now more about this you'll be studying more in science and technology. So this is how it started. See, initially, you have a diffuse cloud. This cloud is nothing but it is made up of hydrogen. And this clump of hydrogen, this dense gas of hydrogen is called as nebula. And because of the gravity, this nebula will be coming together. So the center of nebula, you have concentrated hydrogen gas. And this concentrated hydrogen gas will be giving rise to the stars. So a star will be born in the middle. So I'll explain you the process here. Then I'll show you this PPT. So the first stage is hydrogen gas, and this is nebula. Then because of the gravity, the gas will come together. So in between you will have concentrated gas. And because of the concentrated gas, the temperature in the middle will increase. So temperature will increase. So because of the increase in temperature, the protons and electrons which are there, now they will start moving at very high speed. So basically they will be moving in a very zigzag pattern. So whenever two protons, when they come very close to each other, so when they come very close in a range of 10 to the power of minus 15 meter, because the force between the proton and proton is electrostatic repulsive force. So you must have heard that likes repel, and likes they attract each other. So the proton and proton will be having electrostatic repulsive force, but again if they are coming up with very high kinetic energy, so they will be attached with each other and two protons will be merged into each other. So when you have an element with two protons, it will be called as helium, and this is called as the fusion reaction. So this is how in the stars the protons or the hydrogen is converted into helium. अभी helium किससे टकराएगा? Again एक helium एक hydrogen से टकराएगा with very high speed, almost near to the speed of light. So almost near the speed of light, then it will be converted into lithium. Then again it will fuse, it will be converted into beryllium, then boron, then carbon, etc. So this is how the various elements have been formed in the stars. But again, if you want to form an element of higher order, आपको अगर iron form करना है, uranium form करना है, then star में energy बहुत high होना चाहिए. Because जितना जोर से आके वो टकराएगा उतना ही वो फ्यूज होगा, or else the force between the proton and proton will be repulsive force. So sun is a very average star. So in a star like sun, see at max you will be forming hydrogen helium. So So hydrogen, helium will be formed mostly. Even now the composition of the sun, if you take, so it is around 75% hydrogen and 23% helium. And at max, if a sun is going towards the red giant phase, so यहाँ पे आप at max carbon form कर सकते हो. So it must be having little bit of lithium, beryllium, boron, etc. little bit, very traces. But sun is a very average star. The sun में इतना ताकत नहीं है कि वो higher order elements produce कर सके. Okay? Now I'll be asking you a question. See, अगर sun में या solar system में इतना ताकत नहीं है higher order elements produce करने का, then how come the earth, if you take the composition of the earth, what is earth made up of? The core is made up of the iron, mostly iron and little bit of nickel, and the mantle is made up of the ferro-magnesium silicates, and the crust is made up of lighter silicates. So basically it is made up of silicates and metals. Silicates and metals. The silicate nothing but pathar, rocks and metals. So how come the rocks and metals have been formed in the earth? In fact, most of the earth is made up of these rocks and metals only. So ये कहाँ से आया? Can you tell me? भाई सोलर सिस्टम में तो इतना ताकत नहीं है. Very good, Ritika. Okay. See, I told you, okay, everything is linked with each other. See, जब सोलर सिस्टम फॉर्म हो रहा था, sometime in the past, say this is the solar system which is in the formation stages. So the time of formation of the solar system, okay, because earlier the universe was not as big as it is today. So somewhere in the vicinity of the solar system, so there must have been a supernova explosion, okay, or there must have been the collision of the neutron stars, or there must have been novas, etc. If you are getting confused of all these things, don't, okay, basically supernova. Means सोलर सिस्टम के विजिनिटी में पास में इतना बड़ा धमाका हुआ, मीन्स इतना एनर्जी मिला स्टार को कि हाइड्रोजन कन्वर्ट हो गया आयरन में. द हाइड्रोजन गॉट कन्वर्टेड इनटू हायर एलिमेंट्स सच एज यूरेनियम, थोरियम एक्सेट्रा. एंड ये विस्फोट होने के बाद, सो आफ्टर द एक्सप्लोजन हैज टेकन प्लेस, इसके टुकड़े आके सोलर सिस्टम में गिर गए. So, sometime in the past, you had a solar system which is mostly made up of hydrogen, means you had mostly hydrogen gas, and बहुत सारा hydrogen gas got concentrated in the middle and it has formed the star called as sun. And in the vicinity of the solar system के पास, you had some supernova explosion, and because of that supernova explosion, वहां से आके पत्थर आके सोलर सिस्टम में गिरे. यहां randomly सोलर सिस्टम में आके पत्थर आके गिरे. Now what will happen? See, the 99.9% of the mass is located in the sun. So the gravity will be towards the sun. So gradually what will happen? आपने स्कूल में सुना होगा, जैसे एक ग्लास में आप तेल ले लो, पानी ले लो, उसको शेक करो, थोड़ी देर के बाद उसको सेटल होने दो, तो क्या होगा? तेल ऊपर आएगा, पानी नीचे जाएगा. In the same fashion, after this event, in the solar system, the sun will be there as it is in the middle, and all these rocky fragments, they have come near. जितने भी पत्थर है, जितने भी सिलिकेट्स है, rocks and metals, वो पास में आ गए, and the rest of the gases, the rest of the hydrogen, it was here. It was here. Okay. So this is the scheme. You can see here. Basically something of this sort. You can see it here. So somewhere in the middle, okay, you have the sun and you have a lot of rocky fragments. Now what these rocky fragments will do, these rocky fragments, they also will be attracted with each other. So because of the gravity, and they will hit each other. So when these rocks come together, they hit each other, enormous amount of energy will be released. And this energy is sufficient enough to melt the rocks. जब पत्थर आके टकराएगा क्या होगा? Rock melt हो जाएगा, and these rocks will be fused into each other. And छोटे छोटे पत्थर जो है एक दूसरे से वो टकरा के after collision they will melt and they will form a bigger rock. Okay, now see, okay, with this knowledge you have, if I am asking you why the planets rotate on their axis, can you tell me the reason? From where the planets have achieved rotation? Yellow color is fine? Or should I use green color? See, collision. See, if the planets are colliding with each other, head-on collision, सीधा सीधा आके collide हो रहे एक दूसरे से. So rotation will not be achieved. But if they are having oblique collision, for example, you have an object like this यहाँ पे, and दूसरा object यहाँ पे ऐसा है, ये वाला fragment. So ये आके अगर यहाँ पे टकराएगा, oblique collision होगा, then they will start rotating. So that is how the planets have achieved rotation. It's because of oblique collision, not head-on collision. सीधा सीधा collision नहीं ऐसा. For example, okay, two people are walking towards each other. So एक आदमी दूसरे आदमी को ऐसे कंधे से ऐसे टकराएगा तो दूसरा आदमी घूम जाएगा ना. So वैसे ही planets घूमते हैं and they have achieved the rotation. Now after this, numerous planetesimals, these are called as the small fragments of rock. They are called as planetesimals. So these planetesimals, they have collided with each other. Collide, and because of the heat they fuse into each other and they have become bigger. So ultimately they have become bigger and the current modern day planets have been formed. Now here again let's go back to this diagram here. So you see in green, so जितने भी पत्थर थे वो सन के पास आ गए and ये पत्थर एक दूसरे से फ्यूज होके they have formed the terrestrial planets. Terrestrial, or we can say rocky planets. Now beyond this you also have the gases. So these are the lumps of gas, and these gases will also collide with each other. So since they are far away from the sun, so they are icy, means OB solid hai because of the low temperature. So they will also collide with each other and they will also form the spheres. So these lumps of gas, they have formed the Jovian planets. Jovian planets. Jovian means Jupiter-like. Means these are also called as the gaseous planets and these are called as the rocky planets. So this is how the solar system has been formed. So this is how they have been arranged. So you can see here, if you look at the size of the terrestrial planets, the size is very small. Means the rocks were very less. Rocky planets are, and the gases have been formed. They have been formed as the Jovian planets. Means gaseous का मात्रा ज़्यादा था and rocks का मात्रा कम था. Now don't you think in between these two, there should be a belt where these rocky fragments were unable to collide with each other? Means either they were very small objects or the gravity is not sufficient enough to collide them. Okay, so Adhiraj Pratap Singh is asking, after the supernova state, neutron or black hole is created, so rock are formed in between. Okay, yeah, you're true. So in between these two, in between the gaseous and the terrestrial, you'll be having the rocky fragments which are unable to fuse with each other. Okay, and they are randomly revolving around the earth, and this is called as the asteroid belt. So in asteroid belt, you can say you have the planets which could not be formed. Okay. Now don't you think after this also you should be having a belt which could not form the planets, but these are made up of gases. So here we'll be having the gaseous fragments which could not become the planets. And this is called as the Kuiper belt. And the Pluto is part of the Kuiper belt. So there is an order in the universe. So in between the solar system, you have a very heavy object, सबसे भारी. उसके बाद then ये पत्थर है. पत्थर के बाद fragmented पत्थर है, which could not form the planets, terrestrial planets. उसके बाद gaseous planets है, हल्के वाले. उसके बाद छोटे छोटे gaseous fragments, icy fragments, okay, which could not form Jovian. Then इसको beyond क्या होगा? And beyond this Kuiper belt, you'll be having protons, neutrons, etc. Protons, electrons and neutrons drifting in the universe. And it is called as the plasma state. You can see how beautifully this universe has been created. Scheme देखो यहाँ पे. If you see the scheme, sun, okay, then rocky. Then you have a belt, fragmented rocks called as asteroid belt. Then you have Jovian. Then you have the Kuiper belt. Then you have the plasma. So plasma mein you have the protons, electrons, neutrons drifting like that. And beyond this, you'll be having one more star also. Somewhere far away, you'll be having one more star. And the space between the stars is filled with this interstellar medium. Interstellar medium. जैसे इंटरनेशनल होता है, जैसे इंटरस्टार होता है, इंटरस्टेलर. So interstellar is basically made up of your plasma. So as in when you go towards the sun, okay, यहाँ पे क्या है, प्रोटॉन इलेक्ट्रॉन ड्रिफ्ट हो रहा है। यहाँ आने के बाद क्या होगा, प्रोटॉन इलेक्ट्रॉन जोड़ के हाइड्रोजन बनेगा, लेकिन हाइड्रोजन भी ड्रिफ्ट होता रहेगा। उसके बाद क्या होगा, ओके, वो प्लैनेट्स फॉर्म होंगे, गैसियस प्लैनेट्स। उसके बाद क्या होगा, रॉक्स फ्रैगमेंटेड, एंड आफ्टरवर्ड्स रॉकी प्लैनेट्स। Okay, see, Aish is asking what is plasma. Plasma is nothing but if the proton, electrons or neutrons are drifting apart. Means यहाँ पे इतना भी ताकत नहीं है कि प्रोटॉन इलेक्ट्रॉन के संपर्क में आए, वो भी दूर दूर भाग रहे। एंड जब भी आप नजदीक आओगे वो सारी चीजें जुड़ जाएंगे, बिकॉज द ग्रेविटी इज वेरी हैवी दैट दे विल कोलाइड विद ईच अदर। तो यहां पे क्या, एस्टेरॉइड में क्या हो रहा है, आपका पत्थर है, अलग अलग ड्रिफ्ट हो रहे हैं ना, पत्थर जोड़ने का शक्ति नहीं है, उतना नहीं, पावर नहीं है यहां पे। सो क्यूपर में क्या हो रहा है, गैसेस को जोड़ने का शक्ति नहीं है। उसके बियॉन्ड भी जाओगे आप, प्रोटॉन इलेक्ट्रॉन जोड़ने का शक्ति नहीं है। अंडरस्टूड? सो कल्याण इज आस्किंग हाउ डिड प्लैनेट्स अचीव डेफिनेट पाथ and why don't they collide with each other? See, इसका बहुत सारा थियरीज है, that is called as the string theory. See, आपने okay, for example, if you study the quantum physics, आपने quantum physics में पढ़ा होगा या केमिस्ट्री में भी आपने पढ़ा होगा। See, electrons जो होते हैं ना, electrons, see this is proton, neutron, nucleus. Now, are these electrons randomly arranged anywhere? नहीं ना, there are certain orbits. This is also called as quantization, and this is one of the fundamental principles of the quantum physics. In the same fashion, okay, somebody is saying what is ether. अभी उन सब चीजों में मत जाओ आप, ether क्या है, वो सब क्या है, because you know ether मतलब you know there is a theory that you know ether बोल के एक मीडियम है, एंड उस मीडियम में ओके यू हैव दिस यूनिवर्स। अगेन स्ट्रिंग थियरी अगेन दूसरा बोलता है। तो स्ट्रिंग थियरी क्या बोलता है, स्ट्रिंग थियरी बोलता है कि यूनिवर्स इज लाइक ओके द ओके क्लॉथ, ए स्ट्रेच्ड मेम्ब्रेन इन द यूनिवर्स। सो ये वाला एक स्ट्रेच मेम्ब्रेन है, ये यूनिवर्स है, एंड उसमें ना ये सब पत्थर ये सब रखे गए, प्लैनेट्स रखे गए, आपके स्टार्स रखे गए, वो एक थियरी है। सो मेनी थियरीज हियर। So there is one question here, stars have their own light, okay, emitting state, but planets don't, then how are they part of stars or supernova stage? So let me get your question rightly. Stars have their own light, because inside the stars you have nuclear fusion reaction. The stars are able to emit energy. Stars have nuclear fusion, they are able to emit energy. That's why, so inside the planets, they are not emitting energy. That's why the light is not emitted. Okay? And supernova, how a star becomes supernova and all, okay, you will study in science and technology. I will not be dealing that with right now. Okay? So there is one more question here. If a temperature is less, then how plasma state is possible, sir? Okay, Shanu is asking a beautiful question. See, in the plasma state, the temperature is, plasma state you have these protons, neutrons, electrons drifting away from each other. See, universe कैसे form हुआ था? The formation of the universe started from quark, gluon, plasma, and they have formed this. So after this you require some energy to combine all this together, to combine them together. Then they will be coming in contact with each other. अब ये प्रोटॉन न्यूट्रॉन साथ में आने के लिए, या प्रोटॉन एंड प्रोटॉन साथ में आने के लिए, they have to overcome this you have to overcome this electrostatic repulsive force, and the nuclear attractive force have to come in picture. Till the time the proton and proton does not come up with very high energy and they collide, they won't come near to each other. So this is how they have been formed. Okay, so in your mind, plasma state means high energy state. आपका plasma means high energy, right? ये सब form होने के बाद, see once the atoms have been formed, अभी इसको तोड़ना है ना, तोड़ने के लिए एनर्जी चाहिए. So plasma is ionized gas. What is ionization? Nothing but kicking off the electron. इलेक्ट्रॉन को किक ऑफ कर दिया, अभी एक प्रोटॉन यहाँ पे आ गया, एक इलेक्ट्रॉन यहाँ पे आ गया, इसको बोलेंगे प्लाज्मा स्टेट. सो इसके लिए एनर्जी चाहिए. सो आफ्टर अचीविंग दिस अगेन यू हैव टू गिव एनर्जी तोड़ने के लिए. मीन्स यूनिवर्स में जोड़ने के लिए भी एनर्जी चाहिए, तोड़ने के लिए भी एनर्जी चाहिए. So every process, okay, so every process is exothermic or endothermic. Okay, this way. The doubt is clear, Shanu? Now let's get back to this. So this is how, okay, they have been formed. And one thing which is very important here is, now I have to use red color here. See, again, one thing is very standard in geography. See, blue के लिए अभी तो ठीक है, लेकिन climatology में I'll be using blue color to indicate cool temperature and red color high temperature. Now I'm using red here. Please excuse me. See, according to the nebular accretion theory and planetesimal theory, so these are the planetesimals, and these planetesimals, because of gravity they have come together, and then because of high energy these are the rocks are molten in stage. Rocks are molten here. And then this has achieved rotation, because all the collisions will not be head on. Okay. So I'll turn it to whiteboard. So because of the oblique collisions, okay, it will achieve the rotation on its axis, and then this red ball will become spherical in shape. Now once it has become spherical in shape, it will start losing the heat. So when it will be losing the heat, so gradually it will become cooler. The outer layers become cool over a period of time, and inside the earth, deep inside the earth, you still have a lot of heat trapped. And this heat which is trapped inside is called as the residual heat. Residue means bacha hua. Yes, you are right. Adhiraj, okay, recently China has achieved, okay, the plasma state. No, China, okay, tokamak is a Russian technology, but China is using, okay, entirely different technology. So China is able to achieve even before what, okay, the sun was able to do. That is a different thing altogether. See, the heat which is trapped inside, it is called as the residual heat. And it is this residual heat which is responsible for various geological phenomena. Means, a heat को बाहर निकलना है, ये heat कैसे बाहर निकलेगा? ये heat बाहर निकलेगा volcanism से, right? So when the volcanism happens, the plate tectonics also happen. So the volcanism, the earthquakes, the plate tectonics, all this happen because of this residual heat. जब तक ये heat earth के inside है, all the geological processes keep happening. And the job of the geographer is not to study the processes inside the earth. Means जितने processes surface को affect करता है, man environment relationship को affect करता है, only those processes the geographer has to study. That's why a geographer also becomes geologist to certain extent. So they'll be studying the processes only to certain extent which affects the surface. So that's why in geography we'll be studying the processes such as volcanism, earthquakes, okay, the plate tectonics, etc. Or else geographers should not be studying. Rather geomorphologist padega unko, or rather geologist padega. Okay, understood? So only one thing which is important in this entire chapter as far as pure geography is concerned is this term called as residual heat. Now this heat which is trapped, okay, are you guys following me? Any doubt please ask me. अभी तक कोई doubts है? Are you able to follow? Now the heat which is trapped inside the earth. So whiteboard is fine as compared to the blackboard. So these are all the cooler layers. So inside you still have a lot of heat trapped, and this is all the residual heat. And somehow the heat has to be dissipated. The heat has to be emitted outside. And what are the various ways of heat transfer? There are three ways of heat transfer. One is the conduction, convection, and radiation. See, conduction means layer by layer the heat will be emitted out. Okay, layer by layer the heat will be emitted out. This is conduction. Now, conduction is, so blackboard is more legible. People are saying blackboard is better. I'll shift to blackboard again. You guys are playing with me. Huh? Sure. Now, but here the problem is rock is a very bad conductor of heat. Rock is a bad conductor of heat. That's why the conduction as a process to emit the heat outside is not that effective. Next, what is the other process? Radiation. So radiation भी एक process है, but again the radiation is not that effective. Why? If radiation has to happen, things has to be transparent. अगर earth glass के जैसा होता, transparent होता, then radiation would have been effective. अभी earth transparent है क्या? No, it is opaque. That's why radiation is also not that effective. Now what is the most effective way of heat transfer? The convection. In convection what happens? The molten rock has to move, means the particles will be moving to dissipate the heat. That's why whatever molten rock which is there inside, a पिघला हुआ पत्थर जो भी अंदर है, वो खुद बाहर आके हीट को emit करेगा. And जब भी ये बाहर आता है, उसको बोलते हैं volcanism और ज्वालामुखी. And whenever this volcanism happens, इससे सारे process शुरू होते हैं. Say these are the layers. So this is say upper layer lithosphere. And from inside, this volcanism is coming. This molten rock called as the magma is coming. So it will be rupturing this, puncturing this, and then it will be coming out. लेकिन सारा ही material बाहर नहीं निकल पाएगा. Some material will start flowing under it, underneath. तो जितना भी आएगा बाहर flow नहीं कर पाएगा, थोड़ा बहुत नीचे से flow करने लगेगा. And when this flows sideways, say इधर से जब खिसकेगा, so it will start dragging this plate apart. So it will start dragging this apart. So they will be moving away from each other. And when they move away from each other, इसको बोलते हैं plate tectonics. Plate tectonics means the movement of the plates. And the movements of the plates, okay, is also called as this continental drift. Later on, okay, continental drift theory has come. Now, हर समय the movement of the plates is not smooth. There will be friction, there will be tension, and जब भी ये tension release होती है, you will be having earthquakes. So, for earthquakes, for plate tectonics, for continental drift, what is responsible? The magma which is there inside, the heat which is trapped inside, or the residual heat is responsible. Now I am asking you a question. Acha, what is asking me? Convection I have missed. So in convection, again, see, you can see, I'll be wasting everyone else's time. See, these are the three ways of heat transfer. Okay, conduction, convection, and radiation. Rock is a very bad conductor of heat. That's why conduction is not an effective way of releasing the heat outside. And radiation, because the earth is opaque, it's not transparent. And convection is the very effective way of heat transfer. The convection means the molten rocks which are there inside, they'll be coming out in the form of volcanism. So, a planet is said to be alive only when it has a residual heat inside. Okay? So, what is a dead planet then? Dead planet is not about life. Dead planet matlab that planet which does not have plate tectonics, which does not have the volcanism, which does not have the earthquakes. And a lot of research, okay, related to this is happening, okay, on the this Mars, and also Moon. Some experiments are happening. So till here, you have any doubt? Are you able to note down? So you have some pictures here, you can go through. So this was the Earth around 4.6 billion years ago. This was around 4.6 billion years ago. So at that time, the Earth was red hot. It's all molten. So over a period of time, it started cooling. And this is the present phase. And these are the interiors of the Earth. So inside the Earth, you still have a lot of heat trapped, and this is heat is called as the residual heat. The outer layers have been cooled. Okay. Now let's see, okay, some of the features of these planets, some of the major features of this planet. Okay. So till now, any doubt here? So what all things you have to remember here? The things which you have to remember here is residual heat, very important. So residual heat is responsible for all the geomorphic processes. If the residual heat is there, you'll be having magnetic field. If the residual heat is there inside, the plant is alive, or else it is dead. Okay. Again, this is basic. Okay, they will not be asking this in the examination. No need. And from here, okay, planetesimal theory, as far as prelims is concerned, they will not be asking this. But you should know what is responsible for this residual heat? The collision of these planetesimals. And why the planetesimals have collided with each other? Because of gravity. And plasma, etc. These are all, science and technology point of view. Geography point of view, only one thing which is important is this. Now again, sometimes they might ask, what are some of the important features of various planets? Okay, so we'll see some of the important features of the planet. Now the first planet is Mercury here. Now one thing which is very important with respect to Mercury is see, Mercury is the nearest planet, but Mercury is not hottest. It is not the hottest planet. The hottest planet is rather Venus. Now, the Mercury hardly has any atmosphere. Why? Because more about this you will understand in the interiors of the earth. We will be doing a chapter called as interiors of the earth. We will be doing magnetism. There you will understand this. So, here the solar radiation is so intense that it has stripped away whatever little atmosphere it had. Means the rays which are coming from the sun, they are so intense, means पूरा strip कर दिया, पूरा यहाँ से gases पूरा निकाल दिया. That is one reason. Second reason is Mercury is so tiny that it has very less gravity, and this gravity was not able to hold the gases together. Okay. And thirdly, Mercury hardly has any magnetic field. See, जब तक magnetic field है, the gases will be intact. But why the Mercury will be hardly having any magnetic field? Very good, Shanu, right answer. Yes, okay, Adhiraj, you are right. You guys know a lot. Good. If you feel that I am telling you trivial things, you can let me know. We can skip this part. So PMK booklets में lot of information is there. So I'm just brushing all your concepts. Okay. So few things which you have to remember here is, firstly, the solar wind has stripped off the gases. First point which you have to remember. Second one, okay, it has very little gravity. So that's why also the gases have been stripped. Thirdly, the size of the Mercury is so small, therefore the residual heat which is supposed to be there inside, it has been dissipated out. So that's why you will not be having a molten core. So the Mercury does not have any molten core. If the core is not molten, then magnetic field will not be there. So magnetic field is almost absent. And it does not have a molten core. If does not have a residual heat, the planet is considered to be dead. So it will not be having much of activity such as volcanism, etc. Again, if in the examination, if they are saying that recently the volcano has been observed on the surface of the Mercury, etc. See, I am telling you one trick here. See, any point which has a future scope of discovery, if a UPSC is giving, mark it right. If you know this trick, you will be able to answer at least 10 questions. See, science has a lot of possibility and future discoveries have happened. So through various topics, I will be telling you what all points can be asked. And one more point, it is heavily cratered. Why it is cratered? Because being near to the sun, it has very high gravity. So because of the gravity, lot of planetesimals have collided with Mercury. So itna वहाँ पे collisions हुआ. For example, this way. So Venus is the hottest planet because it has its atmosphere is around 96% CO2. The CO2 will be trapping a lot of heat, and the Venus is also called as Earth's twin because the size of the Venus is almost similar to Earth. That means the Venus should be having a lot of residual heat inside. The heat must be trapped inside because the heat which is trapped inside depends upon the size. अगर कोई planet का size कम है, छोटा है, तो heat जल्दी भाग जाएगा अंदर से. अगर कोई planet बड़ा है size में, a lot of heat will be trapped inside. So since the Venus is called as Earth's twin, inside the Venus there is lot of residual heat. Then, so Venus, so extremely weak magnetic field, and Venus has high temperature. In fact, it is the hottest planet because 96% of Venus is CO2. And third thing which is important about Venus, since it has very slow speed of rotation, it will be having extreme diurnal range of temperature. That means daytime it will be extremely hot and the night time it will be low. And Venus is also called as evening star. Why? Note all these points. Venus is also called as evening star. Why? See, remember this thing, very important. I'm telling you one thing, okay, you note down it everywhere. So Venus has high albedo. Of course, it will be shining a lot. That's why it is called as evening star, and it's because of albedo. Why high albedo? Because of SO2. Remember this. So this is not just useful for the Venus; it is also useful for the Earth. कहाँ ये काम आएगा? Where all you can use this? See, whenever you have this SO2 in the atmosphere, it will be having high reflectivity. Venus has high SO2 reflectivity, that's why it shines, appear to be shining, that's why it is called as evening star. Now for example, okay, you want to reduce the temperature on the surface of the earth. Means sun ka heat jitna bhi aa raha hai usko reflect karwana hai. So there is some process called as cirrus cloud thinning. Cirrus cloud thinning. So in this process, you will be spraying a lot of SO2 in the upper clouds. Okay, in the stratosphere also you can spray. So the earth will also increase its reflective capacity and earth can become little bit cooler. Okay, this process is called as cirrus cloud thinning, and it is also called as geoengineering. So geoengineering is a term which is used when there are large scale changes on the surface of the earth. It is called as geoengineering. For example, you are installing solar power panels on the entire Sahara. Geoengineering. If you are doing a very large scale afforestation, geoengineering. If you are painting a very large surface area on the earth white in color so that the albedo of the surface increases, geoengineering. If you are using jute, in the edges of the Sahara desert so that the sand will not spread further, geoengineering. So any large scale changes on the surface of the earth is called as geoengineering. This is called as cirrus cloud thinning, and it happens when there is SO2 in the atmosphere. Remember this. And these are the points which are important with respect to the Venus. And next point which is important, I am telling you the most important points which can be asked in the examination. Next is moon. So very important points about the moon. So the moon is more about this you will be studying in science and technology. Moon is tidally locked, that means you will be able to see only one side of the moon. And secondly, the moon has extremes of temperature. Extremes of temperature. So this is also the reason why the scientific equipment, for example, Chandrayaan 2 or Chandrayaan 3, when you are sending them, they have to work at extremes of temperature. During the daytime, the temperature will reach to 150 degrees centigrade, and at night time they will go to minus 120 degrees centigrade. So they have to sustain a range of around 200 to 250 degrees centigrade temperature. So in this range, it will become very difficult for the equipment to wake up again. This reason. And the moon equator is comparatively warm, and the poles of the moon have water. So this is also the reason why we are launching our missions. तो जब भी आप चंद्रयान 2, चंद्रयान 3 लॉन्च करते हैं, अब मून के साउथ पोल में जाके लॉन्च करते हैं. क्यों? वाटर अवेलेबिलिटी होती है. So when you have the water availability, So in the future you can establish a station over there, because for humans the water is very important. And how the moon has been formed? The moon has been formed out of the earth around 4 billion years ago. How? So the earth was there, a very big asteroid has come and hit the earth, and the particles which have come out of the earth have collided with each other and they have formed moon. So this surface composition, okay, or the elemental composition of the moon is very much similar to the earth. So these are some of the important points with respect to moon. So next one is Mars. So next one is Mars. So Mars has an average temperature of around minus 67 degrees centigrade. It is cooler. And Elon Musk wanted to establish a colony on Mars by 2022, but it could not happen because of COVID and various reasons. And Mars has a lot of winds, heavy winds. That's why landing on the Mars is very difficult because of these winds. And Mars is called as red planet because of lot of iron content. Again, remember this. So wherever you have heavy iron content, it will be red in color. Remember this. Iron, specifically iron oxide, FeO. Okay. So again, the Mars has a volcano which is around 27 kilometers tall, and it is extremely huge, and it is the largest volcano on the solar system, called as Olympus. So Mars has that largest volcano in the entire solar system. That means once upon a time Mars was also tectonically active. But today Mars is not tectonically active. Why? You can tell, answer. Once upon a time it was tectonically active. Means Mars was as good as Earth around 2.5 billion years ago. But today it is not. Why? Mars had everything. It had rivers, it had oceans, it had rainfall, and probably it must have had life. But today, no. Very good, Ritika, excellent. Because the Mars is comparatively smaller in size as compared to Earth. That's why it must have lost all the residual heat. That's why whatever volcanoes have been made around 2.5 or 3 billion years ago, they still are there. And Mars has lot of fluvial landforms, lot of alluvial landforms. So whatever deltas which are there on the earth, the U-shaped valleys, canyons, etc., which are there on the earth, you'll find on Mars also, because once upon a time it was just like the earth. But now the core has been cooled. Even when the core is cooled, when you don't have a liquid core, it will be having almost zero magnetic field. So these are some of the important points about the Mars. Now after Mars, you'll be having a belt called as the asteroid belt. So all these points are important for the prelims. Note down all these points. So this is where you have the Mars, and here you have lot of fragments, rocky fragments. They could not be collided with each other because of very less mass. Mass is very less. And these are also called as time capsules. Why? So whenever this word comes, time capsule, because UPSC has this strange habit of asking questions. For example, they'll be framing 4 options like this. Time capsule. It is a capsule created by Brian Johnson, which has become very popular in the school of reverse aging. First option. Second option. Time capsule is a drug which has been created with the help of Ozempic and Mounjaro, which has wonderful results in diabetes and hypertension. Option C. Time capsule is such a planetesimals which can be used in studying the formation of the universe or the solar system. Option D, none of the above. So like that they'll be framing. Now these time capsules See, if you study these planetesimals, very good, okay, so Rohit, you're good, frozen records we can say. See, these could have become planets. For example, imagine the size of the sun is larger, say size of the sun or mass of the sun is 2x as it is today. So in this asteroid belt also you could have had a new planet. Since the size of the sun is not that much, and because of the less size of the sun, the gravity is not that much that they could collide with each other, a new planet could have been formed. That means we can say these are the remnants of the earlier planets. Now nowadays we are showing a lot of interest to study this asteroid belt because one reason is commercial. Means here in this asteroid belt you have some asteroid which are completely made up of carbon, such as Bennu. पूरा कार्बन से बना हुआ है, and this is a primitive carbon, means the carbon which has existed around 5 billion years ago. अगर आप एक कार्बन को जाके पढ़ेंगे आपको पता चलेगा लाइफ कैसे evolve हुआ है, because life on the surface of the earth is predominantly hydrocarbons and carbon is very important. Okay, first is the commercial aspect. The second one is in this asteroid belt. Okay, so since this asteroid belt is nothing but fragmented planetesimals, there are some planetesimals here which are completely made up of iron, which are completely made up of rare earth, which are completely made up of gold, diamond, etc. Now, okay, we have sent some missions. NASA ने एक मिशन भेजा, बेनू पे गया, सैंपल उठा के लेके आया. Imagine in future a technology will come where एक रॉकेट टाइप इंस्ट्रूमेंट जाएगा यहाँ पे, वो पूरा गोल्ड से बना हुआ या प्लैटिनम से बना हुआ या रेयर अर्थ मेटल से बना हुआ एस्टेरॉयड को खींच के लेके आएगा अर्थ के ऊपर. सो इन द फ्यूचर माइनिंग कैन आल्सो बी पॉसिबल. दिस इज द कमर्शियल एस्पेक्ट. And the scientific aspect is we can study the evolution of the universe or evolution of the solar system. So Adhiraj is asking a question, why Mars couldn't restrain atmosphere and inhibit water and rainfall patterns similar to Earth when they both, similar situation. See, Mars is comparatively smaller in size. The Mars has 1/3 of the mass as compared to the Earth, and residual heat बचा ही नहीं उसमें. When there is no residual heat, there will not be any magnetic field. Understood? So these are some of the important points about the Mars. These points I have highlighted again. You can go through this, but whatever I'm telling, you can note them down. Asteroid belt also we have discussed. So asteroid belt, millions of rocky remnants from the solar system. Okay, role in planetary evolution. Okay, the Kirkwood gaps. Okay, this point you can note. Again, such kind of questions can be asked. See, the objects in the asteroid belt are not uniformly arranged, because say there is a big planet over here. So the big planet will be having certain gravitational pull, so it will be clearing certain gaps in the asteroid belt, and these are called as Kirkwood gaps. It's because of Jupiter's orbital resonances or Jupiter's gravitational field. And asteroids vary by size. There's called as Cirrus, 940 kilometers in diameter is the largest. Most of them are under 1 kilometer. You'll be having type C, means you'll be having completely carbonaceous. You'll be having S type means silicates, patthar, rock se bana hua hai. Okay. So of course in the inner belt you'll be having this. You'll be having X type also, metallic also you'll be having. Okay. Anyways, I've explained that. Okay. So inner ores are dry, outer holes hold water. Obviously, when you are near to the sun, the water will evaporate. When you are away from the sun, they can be present in the icy form. Origin क्या है? Failed planet है. Next, Jupiter. Okay, very important points about Jupiter. Anyways, you have this information everywhere. Okay, I'm telling you some of the very important ones. Okay, Adhiraj is again asking a question. If Elon Musk is planning to settle the ecosystem and make nuclear bomb attacks on Mars to build atmosphere, still it can't restrain due to the lack of magnetic field. So how it is possible later on? See, what Elon Musk is planning is, Elon Musk is planning to nuke, means he'll be sending a nuclear bomb on the poles of the Mars, and the heat will become so intense. So यहाँ पे जो ice है वो पूरा पिघल जाएगा, पानी आ जाएगा. So this is how Elon Musk is planning, and comparatively the planet will become comparatively warm. So you're asking how you'll be able to protect yourself from this solar wind, because if there is no magnetic field, क्या तब space suit पहन के घूमना पड़ेगा ना? There is no other way, because you cannot produce the residual heat inside. So the next important point about Jupiter. So Jupiter is the largest planet. So Jupiter is mostly made up of hydrogen, helium. And there is one more theory here regarding this Jupiter. For example, say you want two suns in the solar system. आपको 2 sun चाहिए because you are unable to work 24 hours a day. Because रात हो जाता है तो सो जाते हो. So since Jupiter is mostly made up of hydrogen, we have to go to the core, middle of the Jupiter, and nuke Jupiter. So slowly nuclear fusion reaction will be initiated and we'll be having one more sun. So when you have 2 suns, रात कभी नहीं होगा, अब 24 घंटे काम कर सकते हो. Okay, this is a joke by the way. So this is very important point about Jupiter. So hydrogen and helium, and you can see here one red spot over here, giant red spot. So giant red spot is on the surface of the Jupiter and it is of the size of the Earth. And here a cyclonic storm is running for like millions of years. तो जनरली कभी भी कोई स्टॉर्म होती है ना, वो शुरू होता है ख़त्म हो जाता है. मतलब यहाँ पे स्टॉर्म को इतना एनर्जी कहाँ से मिल रहा है पता नहीं. मिलियंस ऑफ ईयर्स से स्टॉर्म चल ही रहा है. एंड द विंड स्पीड्स इनसाइड दिस रेड जायंट स्पॉट आर लाइक ऑर्डर ऑफ थाउजेंड्स ऑफ किलोमीटर पर आवर. इतना तेज़ी से यहाँ पे विंड्स ब्लो करता रहता है. दैट्स वाई इट इज़ वेरी इंपॉर्टेंट. जायंट स्टॉर्म और साइक्लोन दिख रहा है, सो दैट इज़ इंपॉर्टेंट. So next important thing here is largest, and it is protecting us. Means asteroid belt जो है ना वो अर्थ के तरफ आ सकता है, but the Jupiter's gravity is holding this asteroid belt together. अगर Jupiter नहीं होता अर्थ के ऊपर asteroids आके गिर जाते. Okay, so this is the role of the Jupiter. Okay, you can see important points over here. So the most important ones I have already told you. Anyways, you can go through this. Okay, and these are also important. It has got 92 plus moons, and Europa is also very important. It has got icy ocean, and Ganymede. Okay, it's the largest moon here. It also has magnetic field, and Callisto. It is heavily cratered. Now Europa is important here, because it is extremely icy, and since the temperature here is very low, you will be having a solid surface. Now if you want to go and study the Jupiter, or if you want to go to the outer celestial objects, then you have to build a space station somewhere. You can't build a space station on the surface of the Jupiter, because Jupiter is mostly made up of hydrogen. It is gaseous. You won't be having any solid surface. वहाँ जाके land नहीं कर सकते हो. इसलिए तो जुपिटर का जितने भी सैटेलाइट्स है उसके ऊपर जाके आपको लैंड करना पड़ेगा या स्पेस स्टेशन बनाना पड़ेगा. सो दैट्स व्हाई द सैटेलाइट्स बिकम वेरी इंपॉर्टेंट हियर. सो नेक्स्ट इज सैटर्न. Saturn is very famous for the moon, so very famous for its rings here. So there are various theories, why the rings have been formed. Okay, one of the famous theory is when the Saturn was rotating, the centrifugal force was so high that it has formed these concentric rings. And these rings, are frozen gases. Okay, some are having solid surfaces as well. And the Saturn is the second largest planet after Jupiter, and it has the lowest density among the planets. Okay, and of course, all the Jovian planets, they are mostly made up of hydrogen, and of course helium will also be there. Okay, and North Pole has unique hexagonal storm. The Jupiter has red giant spot, this has hexagonal storm, and the temperature of the core is around 11,700 degrees centigrade. Very important, this one. Means the entire planet is extremely cold, but the center of the storm is extremely hot. And liquid metallic hydrogen layer generates magnetic field. So whichever planet is large, again remember this blindly, अगर planet large है उसमें residual reheat होगा बीच में, and because of the differential movement of various layers, a magnetic field will be generated. So even Saturn will be having magnetic field. So iconic rings are made up of ice, rock particles, etc. Now it has 145 plus moons, so highest number of moons. Again Titan is very important, it's the largest thick atmosphere, it has got lakes, etc. So these are some of the important points with respect to the Saturn. Again Uranus, Neptune, etc. not that important. So next one is the Kuiper belt, already told you. So these are nothing but the fragmented gases which could not become Jovian planets, the planet that never could be formed. Okay, and the Pluto is part of this Kuiper belt, and beyond this Kuiper belt you have the interstellar space which is made up of plasma. Now this Kuiper belt, okay, again kitna dur hai etc. you need not remember, but Kuiper belt is 200 times heavy and 20 times larger. Means uska size bada hai, because generally you will be thinking that the asteroid belt is heavier and larger. No, it is the Kuiper belt which is heavier and larger, and it has billions of icy bodies and dwarf planets like Pluto. Again others you can ignore here, remember Pluto here. Okay, again it is mainly made up of frozen water, methane, ammonia, etc. Okay, and mass is also comparatively low here, around 0.1 earth masses. And very important point, the short period comets, they will be coming from the Kuiper belt, and these are also called as classicals, also called as cold classicals, very important. And resonant, okay, Neptune is locked. So I'll tell you about this cold classicals here, once it has been asked in UPSC. So you have this solar system. So you have sun in between. So this is the entire solar system, and beyond this you have Kuiper belt. Kuiper belt, and very far away from the sun, around 10,000 AU away. 10,000 AU. 1 AU is the distance between the sun and the earth. So here we have something called as Oort cloud. Now the objects in the Oort cloud are held by the gravity of the sun, and the objects in the Kuiper belt are also held by the gravity of sun. But sometimes the object can get misfired. So Kuiper belt से अगर कोई बिखर गया या रास्ता भूल गया, now they will start rotating around the sun. They become heliocentric, okay? And these highly elliptical objects, these are called as comets. And since they are coming from the Kuiper belt, the time period of revolution is comparatively low. Sometimes from the Oort cloud also the comets can come, and this will be having a very long period of revolution around the sun. So the source of the comets is the Kuiper belt and the Oort cloud. Now Oort cloud is considered to be the part of the solar system, and it is the maximum expanse of the solar system. So we are discussing, somebody is asking about Neptune planet. See, not that important. See, I am discussing geography here. So I am going beyond little bit of geography. So little bit of all these things I am discussing regarding the solar system and discussing the most important points. See, पहले ज़माने में पूछते थे प्लांट्स के बारे में, आजकल नहीं पूछता है. So आजकल whatever questions they will be asking from this part, they will be asking about the missions, scientific missions of NASA or the ISRO. Or else they will be asking about dark energy, dark matter, all these things they will be asking, or standard model of physics. Okay, these kind of questions they will be asking. So Halley's comet, Aditya is saying Halley's comet 76 years, so it is coming from this, okay, Kuiper belt. Okay, earthquakes है आगे आगे बहुत कुछ बचा है. So this is just the beginning, this is a warming है. So next, some of the important points here. So Pluto is the part of the Kuiper belt, largest known. So Pluto has a thin nitrogen methane atmosphere, heart-shaped glacier. You can remember the name of the glacier here. And 5 moons led by Charon. You can remember this name, Charon here. And Pluto's surface has mountains, plains and possible cryovolcanoes. Cryo means extremely low temperature. Obviously यहाँ पे भी volcano होगा. Volcano is what? Nothing but because of the differential in the heat, convection will be taking place. So when the convection takes place, the material will come out. On the surface of the earth, the material which is coming out is molten rock. And here, the gases which are there on the surface of the earth means यहाँ पे hydrogen निकल के आएगा, पानी निकल के आएगा. So पानी का भी volcano हो सकता है, and these are called as cryovolcanoes. Cryo means if you are working at extremely low temperature, below minus 196 degrees centigrade, it is called as cryo. And these are some of the missions. New Horizons flyby in 2015 revealed Pluto's diverse geology, okay, confirming its Kuiper belt origins. Okay, so again, very similar to your asteroid belt, the Kuiper belt will also act as a fossil record for the solar system because these are the objects which could not become a planet. So that's why if you want the evidence of the solar system, then you can go and study them because they haven't. Because these are very far away from the sun, the radiation must not have been affected these, and there is not much of erosion. Okay, means the rocks or the objects which are there 4.6 billion years ago, they are being maintained in the same state. यहाँ पे कुछ भी नहीं हुआ. So that's why they are called as the fossils, or also called as time capsules. So these are some of the important points, okay, about the solar system. Okay, any doubts regarding the solar system? All clear? So Adiraj is asking, so one question with respect to Mars. Mars is considered part of Goldilocks zone, no, but it doesn't sustain life. Why it is called? See, Goldilocks zone is such a zone where the water is existing in the liquid state. And Goldilocks zone with respect to the solar system is Earth only. Means universe mein, for example, you have a star, some star is there. And at a certain distance from that star, the water can be there in liquid state where life can sustain. Okay, that is the Goldilocks zone. And Mars is definitely not part of the Goldilocks zone because the humans cannot survive over there. Understood? So next we'll enter into, okay, again part of the universe only, बहुत time लग गया as than expected. So can I go a little bit faster here? You guys tell me. If you're familiar with most of the things which I talked about, we can go a little bit faster, or this pace is okay. You can guide me. Faster, okay, fine. Okay, good. So whenever you're familiar with certain topic, you can let me know. So next is type of galaxies. Now what is galaxy? Galaxy is nothing but a constellation of the stars. So all the stars come together, they form a galaxy. And our galaxy is the Milky Way galaxy. Milky Way galaxy is a spiral galaxy. Now the galaxies can be of various types. Now what is the current affairs here? Okay. Now there is something called as relic, reannihilation limited high cloud or cloud 9. So the UPSC will be asking the cloud 9 which is recently seen in the news is what, etc. They will be asking. So whenever you study the current affairs, you will be having certain doubts. I will be clearing that doubt. Okay, I should be using the green one or red one, which is more visible to you. Please let me know. So this red I should use, or green I should use, which is more visible here. Right, okay, fine. Chalo. See, so this is when the role of dark matter will be coming. See, a group of stars will be forming a galaxy, and inside the galaxy you will be having dark energy, right? And because of the dark energy, the galaxy will be collapsing inside a central galactic nucleus, also called as black hole. Means galaxy में पूरे stars है and आपकी dark energy भी है and gravity है. Because of this वो पूरा बीच में आ जाएगा. So there are gravitational pull will be towards the center, and जब भी gravitational pull heavy हो जाता है, infinite हो जाता है, it will be forming a black hole, and black hole is also called as central galactic nucleus. And अगर कहीं पे hydrogen gas है, over a period of time this hydrogen gas or nebula should be converted into a galaxy, and galaxy over a period of time should become a black hole, and it should collapse. But यहाँ पे कहानी में twist है, which is called as relic, because recently we have launched something called as James Webb Telescope. Okay, this is a new telescope which is 100 times more powerful than the Hubble telescope. And this James Webb Telescope has been observing the universe, and it is making a lot of observations. So recently, relic which is seen in the news is associated with what, etc. ऐसा पूछेगा. So यहाँ पे क्या हो रहा है? You have this hydrogen gas. So hydrogen gas होगा तो क्या gradually क्या होना चाहिए? It should become a galaxy, black hole. Okay, this story should happen. But enveloping this gas hole, this hydrogen gas, you have dark matter. अभी क्या होगा? The dark matter will be holding this gas apart. Means hydrogen gas क्या कर? It will try to collapse towards the center, but this dark matter which is surrounding this will be holding it away. Means it is in such a balance that a galaxy is not formed, and that is called as a relic. Understood? Concept clear? You can go through this. Okay, see the magnum which is given to you, इसके बारे में पूरा information है. I am telling you in a very simple manner. Okay, so reionization limited high cloud, also called as cloud 9. Sometimes they can ask this also. Cloud 9, which is recently seen in the news, is associated with what? Okay, it's the cirrus cloud, okay, which has been formed over Canada, okay, which is responsible for ozone hole, like that. They will give one option. समझ में नहीं आया? Okay, so फिर से एक बार समझाता हूँ मैं. See, आपके पास कोई मास है, नेबुला है, हाइड्रोजन गैस है, वो कोलैप्स होना चाहिए, बिकॉज ग्रेविटी शुड बी पुलिंग इट टुगेदर. वो कोलैप्स होने के बाद बीच में इतना ज़्यादा फोर्स ग्रेविटी हो जाएगा कि वो यूनिवर्स को पंक्चर करेगा, एंड दैट इज कॉल्ड एज अ ब्लैक होल. एंड ग्रेजुअली ए नेबुला शुड फॉर्म ए गैलेक्सी, ब्लैक होल, एंड इट शुड कोलैप्स. दिस इज नॉर्मल वे. लेकिन बीच में गैलेक्सी है, लेकिन उसके बाहर आउटर कोटिंग you have this dark matter. This dark matter is not allowing this hydrogen gas or nebula to collapse into each other. So उसको गैलेक्सी फॉर्म होने नहीं दे रहा है. So NASA's Hubble telescope confirms first ever failed starless galaxy. वहाँ पे हाइड्रोजन है, लेकिन वो हाइड्रोजन स्टार नहीं फॉर्म हो रहा है, वो हाइड्रोजन गैलेक्सी फॉर्म नहीं हो रहा है. इसके बियॉन्ड कुछ मत पढ़ना, इतना ही पढ़ो. Whatever is written here, that is sufficient enough. Okay, got it? So Pawan is asking, what is the dark matter, how to prove its presence? See, dark matter जहीं पे, if this dark matter in the universe will be having gravity, For example, okay, my weight say on the ground floor is say 100 kg, but when I'm measuring my weight in the second floor, the weight is increasing to 200 kg. मतलब मेरे वेइंग मशीन के नीचे डार्क एनर्जी है, मेरा वेट बढ़ रहा है वहां पे, मीन्स इट इज पुलिंग मी टुवर्ड्स द वेइंग मशीन. ऐसे कहीं पे भी यूनिवर्स में वैसे ग्रेविटी आपके कैलकुलेशन के हिसाब से और भी ज्यादा है. दैट मीन्स यू हैव डार्क एनर्जी देयर. अंडरस्टूड पवन? Pawan, you know, whichever language you are comfortable in, I will explain in that language. Huh? Telugu means Telugu, Hindi means Hindi, okay? Malayalam means Malayalam, Tamil na pesarum, everything. So next one is this Alakananda galaxy. So Alakananda galaxy is also in the news. It is 1.5 billion years after the Big Bang, located 12 billion light years away. The challenges models predicting chaotic early galaxies, suggesting rapid disk settling, gas accretion and spiral density waves operated far sooner than they thought. See, if you are having a galaxy, okay, which is very old, means right after the Big Bang this galaxy has been formed. Now early galaxies should have been collapsed. मीन्स वो ब्लैक होल फॉर्म करके वो खत्म हो जानी चाहिए, लेकिन अभी तक भी वो जिंदा है. मीन्स टिल नाउ यू हैव दिस गैस स्पाइरलिंग ओवर दिस, इट इज स्टिल एक्टिव. सो दिस इज अगेन द मैटर ऑफ कंसर्न, एंड दैट्स व्हाई दिस गैलेक्सी, दिस अलकनंदा गैलेक्सी इन द न्यूज. सो सिंस वी आर टॉकिंग अबाउट गैलेक्सी, व्हाट इज द नियरेस्ट गैलेक्सी टू द मिल्की वे? मिल्की वे इज ऑल गैलेक्सी. What's the nearest galaxy? You can answer there. Andromeda galaxy. Okay? Andromeda galaxy. And there is a saying that in future, Andromeda galaxy and Milky Way galaxy will collide with each other. They will collide with each other. Say after say 5 billion years, 4.5 to 5 billion years के बाद they will collide. Again, this is in conflict with what you have studied earlier. So this is Milky Way. So this is Andromeda. So between these two, there should be dark energy, and dark energy is responsible for the expansion of the universe. लेकिन वो why they are getting attracted towards each other? It means दोनों के बीच में डार्क एनर्जी उतना नहीं है जितना होना चाहिए, and because of gravity they are getting attracted towards each other. Yeah. Next you have this extreme nuclear transients. See, I'll show you what is happening here. You can see the animation. See, let me play it once again. See, actually extreme nuclear transients means you have a black hole, and near a black hole you have a star. So the star will be sucked into the black hole because black hole will be having almost infinite gravity. So the mass of the star will be sucked inside. Means the star will be fueling this black hole. Meaning because the star will be having hydrogen. So जब भी ये हाइड्रोजन ब्लैक होल के पास जाता है वो घूमने लगता है. So a lot of friction will be there. So because of this black hole will be emitting a very large amount of energy. It will be dissipating very large amount of energy. And such energy generation will outshine the entire universe. Means इतना light निकलेगा, इतना बड़ा धमाका होगा कि पूरा मतलब सन भी छिप जाएगा, मीन्स सन भी नहीं दिखेगा. मीन्स अगर दिन में ये वाला इवेंट अगर हो रहा है, आप देख रहे हो, it will outshine the sun, and these are called as extreme nuclear transients. Okay, in a very simple way. So, venture too close to a supermassive black hole at galaxy centers, extreme tidal forces rip star apart, forming a debris stream that spirals into a black hole event horizon, releasing immense electromagnetic energy through radiation. This is a scientific language which is there everywhere. Again, I am explaining you, okay, in a very simple language. You have a black hole, you have a star. Of course, the star should be larger. Only when the star is larger, it will be having enough hydrogen, enough gas hoga, enough energy hoga. So this black hole will suck in the star, वो घूमेगा black hole के around घूम के, and जब भी वो घूम रहा है, and this घूमने के जो part होता है ना, is called as accretionary disk. And at that time, it will emit a very large amount of energy which will outshine the universe, and these are called as extreme nuclear transient. So nuclear क्यों? Because obviously the energy which is released here is nuclear energy. Transient मतलब क्या है? So transient मतलब universe में, okay, any light source is dimming or getting brightened up. Means अगर उसका light intensity कम हो रहा है या बड़ा हो रहा है, it will be called as transient. So this is the full form of extreme nuclear transient. Okay, Kalyan, very thank you. Okay, I am very famous for that only. I will be making very complex things very simple. But इतना ध्यान रखना extreme nuclear transients. सबको समझ में आ गया extreme nuclear transients? Everyone understood? Good. Excellent. बढ़िया. Okay. Next. Okay, again literature is written here. Extreme energy output will be up to 10 times brighter than the GRBs. Sorry. So one ENT can emit 100 times the sun's lifetime energy. So ये तो अभी तो समझ में आ गया होगा, हाँ? Brightness rises over 100 days, peaks then fades over 150 plus days. Radio emissions persist. No, ये सब information Magnum में है. Okay, don't worry. Huh? So hundreds of times less frequent than supernova. Supernova is nothing but explosion of a star. So it is more brighter than the supernova, explosion of a star. So occurring in large galaxies in massive central black holes. Obviously, it will occur in large galaxies only, because larger the galaxy, bigger stars will be having and bigger energy will be released. Okay, very simple. You can go through. Magnum में पूरा information है. Next is tidal disruption events. Again, I will show you animation here. दिख रहा है आपको? So you have a heavier object here, and if a star is coming in contact with that object or black hole, okay, it is tidally attracting it, and gradually it will be sucked into the black hole. Okay, so यही मतलब है इसका tidal disruption events. So don't get confused. Again, one more animation I'll show you. Okay. So understood? So these are the intense bursts of radiation that occur when a star is entirely torn apart by a black hole's gravity. So these are more common and involve smaller black holes. Means this will be happening. Extreme nuclear transients will be happening when you have a very big black hole, and this will be happening. TDEs will be happening in smaller black holes. Okay. Only this much you should know. Nothing beyond this, huh? Okay, in Magnum these things are there. Okay, in the in the beginning only. Okay, universe वाला chapter में है ये सब. See, many things may not be there in the Magnum. The thing is, in the Magnum only you have this extreme nuclear transients. and going bit beyond. Means agar wo पूछेगा, then they can ask TDs also. Then they can ask fast X-ray transients also. They can also ask for this. And little bit, expanding the horizon here. I can show you animation here. You can see this is the universe. So in the universe, okay, now these things which are happening, this can be a supernova, means explosion of a star. Also it can be the gamma ray burst. Now, fast X-ray transients. See, whenever a black hole becomes very active, it will be emitting a lot of radiation outside. Because when a star is sucked in and when it is rotating in an accretionary disk, and because of the heavy friction, it will be emitting a lot of radiation. And this radiation which is coming out, emitted by a black hole, is called as gamma ray burst. Now generally, you must have learned that even the light cannot escape a black hole, right? Nothing is emitted out of a black hole. No, it's not true. Only when the things enter beyond the event horizon, means black hole के surrounding, जो black part होता है, that is called as event horizon. Only when the things enter into the event horizon, they will not be returned back. The event horizon is also called as the point beyond which the things cannot come back, point of no return. But surrounding the event horizon, you have this accretionary disk. In this disk, when the things are rotating because of the friction, a very large amount of energy is radiated out in the form of the gamma ray burst. उसका थोड़ा lower form है this one. One second. Fast X-ray transients. So this fast X-ray transients very short bursts of X-ray observed when stellar explosions release too little energy to generate gamma ray bursts. Okay. So FXTs are weaker, short-lived X-rays only events, while ENTs shine brighter, longer, and multiple. Okay. So we can put it this way. ENTs then you have gamma ray bursts, then you have FXTs. So this is in terms of intensity and energy. So since we have studied about that, we will study about gamma ray bursts also. Just now I explained. So these are energetic cosmic explosions caused by collapsing stars or merging neutron stars, okay, emitting intense gamma radiation. So GRBs were earlier considered to be the brightest explosions, but ENTs usually emit greater energy and last longer. So this is the very recent discovery, ENT. In the Magnum you will be finding ENT, okay, only ENT is there. So expanded ENT into GRB and FXT for comparison basis. Because UPSC will never ask a question from the first layer, second and third layer se question पूछेगा, okay? So Pawan is asking, I changed my optional to geography, can I contact you? You can give, yes, sure Pawan, okay? You can take my contact number, you can contact me. Right. So I hope you have understood. Don't complicate the things here. I am telling you in a very simple way. See, for example, these are two neutron stars. So when they will be colliding with each other, so they will revolve around each other and they will release humongous amount of energy. So this is the gamma ray burst. Okay, इससे भी अगर खतरनाक powerful okay explosion हो रहा है universe में, that is called as ENT. Okay. So next, the solar system.